In this video, we're going to finish up the hypothesis test, well, almost, by deciding to reject or not reject the null hypothesis. That's the question. We'll always reject or not reject the null hypothesis because that's what we've assumed to be true. We're not trying to go out and prove that the alternative is true. We have a fixed number as your proportion in the null hypothesis, or maybe your mean, and that's what we based our normal model on. And then when we gather our data, we're trying to compare our sample mean or sample proportion against what we assume to be true. So when our sample is really far away from the mean, think of like the empirical rule. If you're about 2 standard deviations from the mean, you've captured about 95% of all possible means. Well, that 2 is roughly a guide for us to decide if we have to reject the null hypothesis or not. Technically, we're going to base this on the critical value, which we did a couple steps ago. So we're back to our example about the data gathered about students graduating college or completing their degree within 6 years of starting. In 2009, the rate was 52.9% completing college, and we want to see if that's enough evidence to say that more than half of these students have completed college. Yes, it is half, but is it significantly more than half? Like maybe we just got a funny sample. We'll figure out how far out in the tail our sample is. So if you recall from our other videos, we had set up the hypotheses that the proportion is 0.5 that we assume to be true, and we're trying to see if more than half have completed college within 6 years of starting. In another video, we computed the critical value. We know it's a right-tailed test because that word more. We have computed the test statistic. Our sample proportion of 52.9% is 1.83 standard deviations above the mean. And then we use that test statistic to compute the p-value. So the area beyond 1.83 is 0.0036. So when we decide if we should reject our null hypothesis or not, I'm going to go back to a picture. There's 2 ways to do this. The first is to look at the critical values. So 1.645 was our critical value. And we're going to compare this against our test statistic because these are both z-scores. They're analogous. 1.83 is a little bit further to the right. Let's see if I can squeeze in 1.83. And from that critical value video, we learned that if we fall in the tail, in this rejection region, we will then reject H naught. So what do we find out? Z equals 1.83 falls in the rejection region. So we reject our null hypothesis. So our sample proportion was far enough away from the mean to say that it shouldn't really happen by chance, that there's something else out there happening. The alternative is that we made a mistake. That's called a type 1 error, but we'll talk about that in a different video. The other way to decide if we should reject H naught is basing this on our p-value and alpha. So we know we were given that alpha is 0.05. And our p-value is 0.0336. And since 0.0336 is less than 0.05, the p-value is less than alpha, we are going to reject our null hypothesis. So same conclusion as with the critical value over there. Now here's where this makes sense. This area that I'm shading right here, this orange, which is not really hard to see, the pink part, I'm going to put a better arrow in there. Oops. So this pink section was 0.05. This orange section over on top of that, that's your 0.0336. Since the area in the tail is smaller than our significance level, it's another way to say that our test statistic is further to the right. It's more extreme than that critical value cutoff that we decided was going to be our cutoff for unusual sample proportions. So there's an analogy here that your test statistic is to your critical value as your p-value is to your alpha value. You don't have to do both of these comparisons that I did in black. Just pick one or the other. If you're using technology, generally the p-value is easier because all computers spit out a p-value. You don't have to look up a critical value. You just have to look at the p-value, decide if it's small or not, and then reject or not reject your null hypothesis. This is what most people learn. Here's a little phrase. If the p-value is low, H naught or HO must go. There you go. If the p-value is low, H naught must go. That's how you know if to reject your null hypothesis or not. So second example, critical values. We were looking for a change. Is 52.9% different than 56.1%? In previous videos, we'd come up with two critical values. We had to split our alpha into two pieces because of this two-tailed test. So our critical values ended up being a little bit bigger and smaller, 1.96 plus and minus. And our test statistic was negative 2.04. So our test statistic is actually 2.04 because in a way we kind of have a positive one, technically not, but if you can imagine drawing negative 2.04, both of these in here, they both fall in the rejection regions. When we found the p-value, we were finding the area in the tails, so to the left of negative 2.04, and then we doubled it, which is the same as the area to the right of 2.04. So we added those two numbers together to get 0.0414. So back to the critical values, we reject H naught because negative 2.04 fell in the rejection region. And then similarly, since 0.0414 is smaller than 0.05, that significance level, we reject H naught. We get the exact same conclusion. We've just looked at it two different ways. So again, don't do both of these when you're doing a hypothesis test. I'm doing both because I'm trying to show you how they are so similar to one another and just to teach you, but in practice you'll only do one of these. And lastly, so that was a two-tailed test. Here's a one-tailed test. We were trying to see if 52.9% was less than 56.1%, a rate from prior years. And we're testing the claim at 0.05. So we'd set up our hypotheses with the proportion equal to 0.561. We're testing to see if it's less. We had a critical value. We computed a test statistic, and we computed a p-value. Now we just have to draw our conclusion. So negative 2.04 is a little bit further out to the left, negative 2.04, and that is our test statistic. So we definitely landed in that green shaded region, which was our rejection region, and then I'm shading orange right here. That is our p-value. So that p-value there is the 0.0207. And then the alpha was 0.05. So because our test statistic is further to the left, that means there's less possible area to the left. So that means our p-value is less than our alpha value. So to conclude that, since negative 2.04 falls in the rejection region, and because 0.0207, the p-value, is less than 0.05, the significance level, we reject H naught. So all we've done in this video is decide to reject H naught or not. There's still one more step after that, and that is to actually bring all this back into regular people terms instead of talking such math language, and we'll write our conclusion in a plain language.